I think I just said hi. Morse code was basically this long-distance communication form long before we had all the fancy technology we have today, made up of signals of either a long signal or a short signal. And combining these short and long signals, you can make up characters and words, and well, you can communicate. What I hope I spelled out there in the beginning was ... pause ... which should read hi. Each character and digit in the alphabet is represented here with a very specific sequence of dots and dashes, or shorts and longs. And you can represent these dots and dashes in a number of ways, similar to what I just did there in the beginning with a flashlight. You could tap something, you could use sound, or you could use electrical signals, which kind of brings us into today's topic. This is so bloated, right? Look at how many keys we need in order to represent an alphabet, but we know better. We don't really need all of those buttons. We only need one, right? That's the goal of today's video. I'm creating a Morse code keyboard using an Arduino Uno. So before we begin actually building this Arduino Uno one-button keyboard using Morse code, in order for us to achieve this, we kind of want to put the Arduino in a human interface device. So basically the computer will recognize the Arduino as being a keyboard or an input device, just as a mouse or a joystick or whatever. Let's create a very simple circuit with a button and an Arduino, and then we will program it, and then we'll take it from there. As for the circuitry in this project, I mean, there's not much to it. You connect the button to the Arduino, where one wire will go to ground and the other wire will go to digital pin 6. Alright, so jumping into the code, after we've set up our button pin to be pin number 6, we want to add a new function that we call signal incoming that will just tell us if the button is being currently pressed or not. In the loop function, we'll add a piece of code that lets us intercept the push of the button and also calculate how many milliseconds this button was pushed down. Next up is to kind of determine if this duration is to be considered as a dot or a dash, and we'll use dot length to kind of determine that. The dot length will kind of decide how long is one dot and how long is a dash. I believe a dash is like 3 dots or something, and it basically sets the pace of the communication. I'm specifying my desired dot length in the code, and then I'm adding a helper function called character from signal duration that will translate a duration to a dot or a dash. We'll create a symbol buffer that will hold kind of all the dots and the dashes. So next thing that we will do is to see, is there another button push coming? If it is, then we'll kind of start over and look for another dot or dash. Otherwise we will go into the rendering. So Morse code to character index is the function that will do that for us. It will translate a sequence of dots or dashes into an index where A is 0 and B is 1, etc. As I mentioned, the Arduino will act as a keyboard or a HID device, and for us to be able to do that, we need to figure out what key codes are we to send to the computer. We look in the HID usage tables for USB devices, and here's what we're looking for. So the key code or the usage ID for the letter A, for example, on a keyboard would be 04, B is 05, and C is 06. So the key code for the character A is 04 in hexadecimal, so we can simply send the character A, or the key code for A, plus index that we got from the Morse code to character index. We'll add a last check here to see if another signal is incoming. If we don't intercept a new signal, then we'll take that as kind of the word is done. We'll automatically send the key code for space to kind of create the new word. The last function to kind of add to this program is just a function that will send the key code over to the computer. We'll call the function send character, we'll pass in the key code that we want to send, and that's it. The application is done. The very last thing we have to do is to turn the Arduino from just an ordinary Arduino into a fully fledged keyboard. To do so, we'll use a DFU programmer, where DFU stands for Device Firmware Update. So we'll update the firmware to be recognized by the computer as an HID device rather than, well, an Arduino. First, we're going to have to connect these two pins before uploading the keyboard firmware. I'll use a jumper cable here to connect them, and when that's done, an LED will blink. Heading on over to the terminal where we will upload the firmware. I've put together a script to do this. The upload will only take a second. Now we're ready to power cycle the Arduino by disconnecting and connecting the USB cable. And that's it, the computer now recognizes the Arduino as a keyboard. So I got this working, I was super happy, but it didn't quite feel like a Morse key, which I learned is a thing. So I figured, hey, I have a 3D printer, I can 3D print something that looks a little bit more like a Morse key. This looks way more like a Morse key. It's 3D printed, it's got some nuts and bolts to kind of hold it together, and in there I have a spring so that it's kind of nice and clicky. So let's have a look at this in action. With the right training, I believe I can master this and become even faster than with my regular keyboard. Maybe not. I hope you enjoyed the video. I hope you found it inspiring to create keyboards with Arduino Uno. Doesn't have to be a Morse keyboard, but that's pretty damn cool. Awesome. Bye.